Hello, and thank you for joining me for this lesson on composite functions. My name is Matthew Neubeck, and I'm very excited to be applying for this position as an upper school math teacher. So I will deliver this video as though I am speaking to a class of students who are unfamiliar with the material, and I'll be interacting with the imaginary class that is behind my monitor. So without further ado, let's get into the content. Normally, I am used to delivering material either while writing on an overhead or, sorry, I have a cat who I'm also shooing away from my keyboard, either delivering material on an overhead projector or on a whiteboard. So this is this is not my favorite way to deliver this content, but I think it makes it the most legible and lets me kind of build the content the same way that I would build it in an actual classroom. So here we are, we're talking about composite functions, and the first sort of fundamental concept I would like to make sure that everyone has an understanding of is the idea of the domain of a function. So this is kind of a mathematical way of seeing this, and I wanted to show it to you because you might run into it this way if you're using a textbook or another resource. The domain of a function f is the largest set of real numbers for which, it's a great grammar, for which the value of f of x is a real number. What does this mean? Let's make sure that we understand this. Rafa, nobody cares what you think it means. Go on over there. The domain, this is input values. We're going to take some numbers and we're going to plug them into a function. And you're going to see what that actually looks like in practice in a moment. And the largest set of real numbers. So this is a collection of numbers that we're going to plug into a function for which the value f of x is a real number. So what we want is the output of the function to be giving us real numbers, nice numbers. Okay, so the way that I usually describe this is it's a list of numbers that we're allowed to plug into the function. We're not going to plug them all in, but just which ones am I allowed to plug in? For example, you can plug in positive numbers or negative numbers or even numbers, right? It's going to be a group or a list of numbers. So that's what domain is. Let's look at some examples. Let's make it real, okay? This function is called f. The numbers that we're going to plug in are going to go into this position. And if we change that x to a different number, then we have to change this x to that same new number and this x to that same new number. Now I'm writing here using a touchpad on my laptop, so I apologize for my atrocious handwriting. But I would ask students first to evaluate maybe f of 2 and have them take a positive number and plug it into the function, do the calculations. Um, I will ask my students for them to do the calculation and tell me what they get for an answer. And then let's plug in also a negative number. Someone give me a negative number. What number should we plug in? -3. Great. So let's evaluate f of -3. And we've got a positive number and a negative number. Is there another kind of number that we should consider plugging into our function? 0. Yeah, that's right. That's between positive and negative numbers. So let's also evaluate f of 0. Now, to save time, I'm not going to, in this video, go through and actually do these calculations, but I would complete that illustration. And then I would move over to this, which is called a rational function. And it's called a rational function because it involves a fraction, but as you can see, the variable is in the denominator of this fraction. So that's the reason we need to pay extra special attention to this function, which is called g. These are not very creative names for our functions. We could change this g and we could call it Skittles if we want to. You could name it after your pet, or after your best friend, or after your brother or sister, right? We can call it whatever we want. But this one's called G. It's very boring. Now, give me some recommendations. What kind of a number should I plug into this function? Positive number from one person. You're recommending a negative number. Great. You're recommending 0. Great. We could go through, plug all those in, do the calculations. But let me ask you this. Now that we've done all those calculations, is there a particular number that you think that we should not plug in to this function? Is there a number that if we plug it in, it's going to cause us some problems? Recommendation of zero, but we already plugged in zero. So there is this maybe a little misconception that when the variable is present in the denominator that we don't want to plug in zero. You're correct on the zero, but it's not that zero can't go in as an input value. In fact, g of zero is equal to 2/5, which is just fine. But let's try plugging in an input value, an x value of -5. And again, in this video, I won't go through the process of doing that. We're writing it out because this is brutal. But plugging in the x value of -5 gives us a denominator of 0, which causes division by 0. And class, when we divide by 0, if you put that into a calculator, you're liable to get an error message. And really, the reason for that is because how many times does 0 go into 2? The answer is actually infinitely many times. And we math people say that infinity is not a real number. And so we don't want to get involved with numbers that are not real. So we avoid division by 0 so that we don't get answers that are unreal. They're just too big. Infinity's too big. So make note of the fact that we want to avoid division by 0. And there are some other ways that we could go through and do some proper arithmetic to really discover the problematic values for this denominator. In other words, the -5. And then again, in this video, I won't do it, but I would write out the different representations of the domain, all real numbers excluding the number -5, whatever the textbook has been using as we've been going along, if that's interval notation, set builder notation, illustrating it on a number line, or however else everyone else is doing it who's teaching this same course. And then I would go through the process, same kind of back and forth, getting recommendations for students to make some suggestions on what we should plug in for x, illustrate what happens with an x value of -2, and then also a value that's even more negative. So talking about the fact that 0 under the radical is okay, negative numbers under the radical is not okay, and then again, illustrate the domain using all of the appropriate styles for illustrating that, different notations. All right, so we've looked at domain here, all real numbers, domain here, one excluded value, domain here, a bunch of excluded values. Let's keep moving. I just want to mention this briefly. Again, this is something that, depending on how the textbook is structured, I would address this whenever appropriate, based on how the content is organized in the book or however the department has decided to move through it. But just to remind students that we can take functions and add them, subtract them, multiply them, divide them. Looking at this notation here on a whiteboard, I would also draw this little dot between the f and the g to illustrate multiplication. That dot could exist right here. Here we're seeing that it does exist. And just so that you don't think I'm losing my mind, this is supposed to be an equal sign, and this is supposed to be a does not equal sign. This is just a PDF issue. These are examples of functions that I could go through and build all four of these, and especially for the rational function, I would talk about domain constraints there also. But in this video, I'm not going to do that because I want to keep moving toward the destination of talking about composite functions. Now, class. Here we're talking about composite functions, which is we're not adding, subtracting, or multiplying or dividing the functions in order to have them interact with each other. We're actually taking a function and putting it into another function. So we've seen g of x, we've seen f of x, but here g of x is being put into the f function. So that's different from what we've talked about so far. And this is one style of notation that we use in order to represent a composite function, where one function's inside of another function. This is another way of representing one function inside of another function. Now, class, please tell me which function is inside which? Is G inside of F or is F inside of G? G is inside of F. That's correct. You can literally see it, right? G is like sort of wrapped up inside of F. Looking at this notation, which function is inside of which? Is F inside of G or G inside of F? You're correct. You're saying you're not sure that it's G inside of F, but that's your best guess, and it's a great guess. Um, in fact, if you look down here, this statement is telling us that those two notations are actually equal to each other. So it's literally two ways of representing or saying the same thing, that we have function inside of a function. Now the conversation about domain gets a little bit more tricky. But before I move on, something that I want to make sure you watch out for. I don't know if I would call this a common misconception or just a common error, but sometimes students look at this, especially if it's in very small font, right? If the type is really small, some students will look at this and think that it's the same thing as multiplication, whether it's fg of x, or maybe there's a little dot between them. And that didn't end up looking like a dot, but it was supposed to. Just get a little dot there, and then the x afterwards. These two statements are not equal, and often the f and the g are wrapped in their own set of parentheses. You got to be careful, class, looking for the hollow dot, which is telling us that we're working with function composition, versus a solid dot between them, or no dot between them that implies multiplication. So make sure that's highlighted in your notes. And if you need a minute to do that, I will pause. Otherwise, let's keep talking about function composition and domain. Now, let me scroll back for just a moment. When we were talking about these functions up here, we took some numbers, 2 and -3 and 0, and we put them into this function, which meant we put them into here and we put them into here. So you've got that in your notes for reference, which is great. And then we did the calculations and we got answers for these, right? So for these would already be written up, but now I'm going to go back and do one of these. 4 and 2 is 6 minus 12 is -6. So the input value is 2 and the output value is -6. Could I take this -6 and like move it over here and plug it into this function? Yeah, I could do that. I could take the -6 as an output value and turn it into an input value going into some other function. That's a possibility. And in fact, that's exactly what's happening when we work with composite functions. We're taking a number like 2 and putting it in here for x, and then we do the arithmetic, and this turns out to equal -6. And then the f function comes in here and operates on the -6, and we get yet another answer, and that's our final answer. Okay, that's the output from the composite function. And I would pause to make sure there are any questions. If anybody needs additional time to write anything down or clarification. And class, anytime you have a question, don't hesitate to interrupt me. You can get my attention by raising your hand or saying, Mr. Newbeck, and then I will pause as soon as is convenient and make sure that we address your question. I might just need to finish a thought that I'm having, and then I'm going to come back to you. So again, don't hesitate. Here we're seeing a really mathematical representation of composite functions in this gray box. So you can read through that, but I think one of the really important things that's in here is the fact that these two statements are the same. In those two statements, in a way, there are three ingredients. X is the initial input value, which you could write down. I'll give you a moment to write that down. G of x is the result, or is an output. G of x is the output. And then we're going to take g of x as an input also and plug it into the function f. So x is the initial input, g of x is the output, which then becomes the input going into f. And once I put that into f, what's going to come out of there? That's correct, class. You are geniuses. F of g of x. That's the ultimate output. That is the result of the composite function. This is a really old illustration, but I think that it still works for what we're talking about. X is coming in here as an input value. It's going through the G machine, and what comes out of the G machine is called G of X. And then that output is going in as an input through the F machine, and coming out of the F machine, ultimately, what are we calling that ultimate output? Either one of these. Now, making sure that everybody has that written down, I have to say, we've looked at some of these things where we're working with actual numbers, but then we've started talking about composite functions, and yeah, I don't see any actual numbers in here, so this is difficult for me to grasp. Anyone else? A little bit difficult to grasp? Yeah, it's like it's just kind of floating around, and I don't really know what we're talking about. F's and G's and X's. Let's look at an actual example in order to try to solidify this. Now, normally in a PowerPoint presentation, I would drop each one of these elements onto the screen at one time. If I'm putting this up on the board, I would put up one line at a time as I build this. So in this example, we're going to talk about profit and the calculation of taxes. And the other elements of that, there's profit, there's taxes, and the other element, the third and initial element, is the number of units sold. So class, here's what I'd like you to write down. First, I want you to write down a little title for this example, and you can use this title. And then I want you to write down this first element, that X represents the number of units that we're selling. Now, I don't know if any of you own your own company. Anybody here own their own company? No one owns their own company yet. Okay, you might get there. What happens when we own a company and we make money, we have to pay taxes. And you've probably heard of taxes. So that's what we're talking about in here, is a company paying taxes. Before you pay taxes, though, before your company pays taxes, you're going to figure out what your profit is. And that's how much money your company is making after they pay for things like keeping the lights on, paying the power bill, paying the water bill, paying employees, raw materials, things like that. That's a longer conversation, but that's what this statement means, is subtracting out the fixed costs. Costs of doing business leaves us with our profit. And once we know how many units we're selling, this is a little formula that will help us figure out how much profit our company has made. Once we know what this number is, which is represented by g of x, so that's the name of the function, g, or we could have called it p of x. We could have called it profit of x. We could give this function a legitimate word as a name. We could call it the profit function. But for the moment, it's g of x, because that's what we've been using so far in this conversation. Once we figure out what the profit is, we're going to take the profit as a number, and we'll drop it in place of y into the f function. Now, this f function calculates how much taxes we actually owe. Remember when you took your $1 water bottle? But we didn't talk about that yet. So let me give this example. If you wanted to buy a $1 bottle of water at a convenience store and you walked up to the counter to pay for your $1 bottle of water, how much would the person behind the cash register actually ask you for? Not sure. Well, would they ask you for a dollar, or would they ask you for more than a dollar? That's correct. They would ask you for more than a dollar. In fact, they might ask you for $1.06, because the Florida state sales tax, depending on what your county you're in, is 6%. So they calculate 6% of a dollar, which is 6 cents, and then they charge you for the cost of your item plus the taxes, so $1.06. That's 6% tax. In this case, we're working with 25% tax, which means if your bottle of water cost $1, they would charge you $1.25. Gee, doesn't that seem unreasonable? Well, maybe it does, maybe it doesn't. But anyway, those are the numbers that we're using in this conversation. So once we figure out how much profit we have, and we take that number and we drop it into this taxes owed function, we're going to figure out what 25% of your profit is, and that's what we have to pay in taxes. In fact, this is really nice having these two things next to each other because 25% as a decimal is 0.25. And profit in this example problem is being represented by the variable y. This is your y value. Okay, that's your profit dollar number. And the word of, as a matter of fact, translates directly into multiplication. And I can't draw my arrows small enough with this marker and digital pen, but there's multiplication happening right there between the 0.25 and the y. So in your notes, you could put a little multiplication symbol in there if you want to make sure that that's clear. So now let's look at the composite function. We'll clear some of this out of the way. Our composite function. So what I want to do, what we're going to do is we're going to build f of g of x, and g of x is on the inside, so we're plugging g of x into the f function. So I'm going to take this g of x right here, and I'm going to plug it in or replace my y value with this expression, which means that we need to replace this y value with that same expression. And when we do, this is the resulting expression. So if y'all will write that down, and then once you've written it down, let's distribute multiplication. The 0.25 is multiplying out and over our grouping symbols, and we get finally our composition function, or our composite function, is 12.5x minus 125. Now, if there are any questions, field any questions. And then I have this follow-up question for you. What is the domain of this function with no context? Like if you just saw this function walking down the street and you asked yourself, I wonder what the domain of that function is. Well, let's look at it. Is there any danger of division by zero? No, there's no division happening at all. Is there any danger of square rooting a negative number? That's right. There's no square root symbol, so there's no danger of square rooting a negative number. There are no restrictions on this function at all. There's no danger. We can take a positive number, a zero number, or a negative number, plug it into here, no problem, mathematically. So you might be tempted to say that the domain of this composite function is all real numbers. You can plug in anything you want. And again, I could write down the various notations for all real numbers. Now, class, I've got some different things I want you to try. First, if we sold 15 units, I want to determine the tax that we would have to pay. In other words, I want you to find f of g of 15, and I'll give you a moment to do that. And the class takes their time, and class, please write down your answer to what you think f of g of 15 is. And any brave souls want to tell us what you got for an answer? Oh, that's very good, 62.5. Now, please, someone else actually, tell me 62.5 what? Pounds? Is it feet? Is it miles? It's dollars. That's right. We've been talking about dollars because we're talking about profit and selling things. So $62.50 is the what? Is it the number of units that we sold? $62.50. Is it our profit that's $62.50, or is it the amount of taxes that we owed? Yeah, that's right. It's the number of taxes that we owed. Good, because that's what the composite function represents. Now, I want to split the room in half. right-hand side of the room over here, your right, my left. I want the right-hand side of the room to calculate, figure out how much tax do we owe if we sell 10 units. And then I want the left-hand side of the room to do the same, but I want you to calculate taxes that we owe if we only sell 5 units. All right, right-hand side of the room, what did you get? Zero. Yeah, that's right. So what does that mean? You pay $0 in taxes. That's correct. Happy about that? You don't have to pay any taxes. That's nice. We'll have a longer conversation why it'd be better off paying taxes. Why aren't we paying any taxes? Not sure. The formula just told me that I'm not paying any taxes. We could go back through and I could put it up on the board quickly and illustrate why it is that we're paying zero taxes and highlight it that it's because we are not making a profit. We could talk about the break-even point if that hadn't already been a prior topic of conversation. So I could go through and illustrate that, but I want to move over to the left-hand side of the room, and I want y'all to tell me what are we paying in taxes if we only sell 5 units, 5 bicycles, 5 bottles of water, whatever the things are that we're selling. You get an answer of negative 62.5. That is correct. Does it seem reasonable to you, anyone on the left side of the room, that we pay negative $62.50 in taxes? No. Very good. Why not? Because paying negative dollars seems strange. Yeah, that's very good. Typically, we don't pay negative numbers of dollars. So let's bring it back to our very first topic of conversation in this lesson, which is domain. In the context of this question, does putting in a 5 into our composite function and getting an answer of negative $62.50, does it make sense? Does 5 seem like a good number that we should plug into our composite function? No. Very good. Um, do you think 6 or 7 or 8 or 9 would be a good number to plug in? Not sure. We could go through and plug in each one of those numbers also. I'm going to tell you that if we plug those numbers in, we're also going to get a negative dollar value for what we would have to pay in taxes. We have to sell at least 10 units before we get an answer that makes sense. $0, paying $0 in taxes. I can imagine that better than I can imagine paying negative 62.50 in taxes. So let's write up the domain for this function as being greater than or equal to 10. And we'll write up all the different ways of representing the domain for this function being at least 10 units that we have to sell. All right, greater than or equal to 10. Excellent. So let's just do a quick recap. We talked about basic functions, some different types of functions that have different little danger elements that we have to watch out for as we figure out what the domain is, and that some functions have no restrictions. In fact, sometimes it's all real numbers. Sometimes we have to avoid one number. Sometimes we have to avoid a bunch of numbers. And then we looked at adding, subtracting, multiplying, dividing functions, the algebra of functions. We just glanced at those briefly before we came in and talked about composite functions. And then we talked about domain again, and that there's an input and an output, which becomes an input, which becomes an output. You can go back through your notes and see that flow of the value as it moves through the machine to give us our final output value. And then we came in and we talked about this example where we had number of units sold was our input, and then the first output value that we calculated was a net profit value, and then that became input. We multiplied it by 0.25 to figure out how much tax we owe, and that only some of those input values gave us a reasonable output value, which tied it back to domain. So if there are any additional questions, anything that you would like to go back to, class, I will be happy to field your questions. If you need additional time or you really want to get into the nitty-gritty of something, let me know and we can schedule a time to meet and really make sure that you're up to speed on everything that we talked about today. And otherwise, that concludes our lesson on composite functions. And the one thing that I didn't mention in the little recap was watching out for the difference between f of g of x, like fog notation, and that multiplication symbol between the f and the g. So don't confuse multiplication with composition. So that is how I like to go through and build and make sure that all of the concepts are there foundationally as we move forward into the complexity of a particular topic. And well, that's a lot of fun. I like going through that stuff. I love the details of that, and to do all that on a marker board would certainly be, I think, a better way to illustrate this and move through it step by step. I don't love having everything up on the screen all at once, but the idea of moving the entire class forward together as best possible and answering questions as I go is really important, and encouraging students to ask questions without fear of being sort of criticized by their classmates, because we all have questions, and when we all have some different topics that are going to be challenging. So I have some different activities that I like to do and questions I like to ask students to encourage them to not be shy about asking questions and make sure that they don't get left behind. And I guess that's it. Thank you so much for this opportunity. I appreciate it, and I hope to talk to you soon and perhaps work with you soon. Thanks again.